Hi everyone, welcome once more to our YouTube channel, our Best Science Brain YouTube channel. Today we're going to run a physics experiment which is aimed at determination of the effect of dissolved substances on the boiling point of water. We know that from theoretical physics that when a substance is dissolved in a liquid, it tends to raise its boiling point. So in this experiment, our concern is to determine the effect of dissolved substances on the boiling point of water. And then the substance we're going to use is common salt. The equipment we need are on the table here. We need a 500 ml flask or beaker. We also have another beaker, a smaller beaker that contains 200 ml water, more than 200 ml of water. So we're going to measure 200 ml of water into this beaker. So we're going to do that right now. Measure 200 ml of water into this big beaker. So pour water onto your tin, about 200 ml of water. So let's be very sure of the volume we are using. Add more. So that is actually about 200 ml of water in this beaker. So having done that, we also need a thermometer for the experiment. We also need a stirrer for the experiment. We also have some measured amount of common salt wrapped in white paper, 10 gram, 20 gram, 30 gram, 40 gram, 50 gram. So how we're going to do the experiment? We're going to boil the water on the burner and then determine its boiling point and record it as BO. That's the boiling point of water. So after we obtain the boiling point of water, then we'll now start adding the salts, 10 gram. You add 10 gram, the water will stop boiling, and then the boiling point will rise to a new boiling point, recorded as BI. After that, we add 20 gram to the mixture, and then get a new boiling point, which we record here. We do that of 30, 40, 50, and record their new boiling points. Then we now evaluate theta, which is BI. That this value minus the boiling point of water, which we're going to determine by experiment. After that, we're going to plot mass against theta and then determine our slope. So let's go to the question. So go to the question, determination of the effect of impurities or dissolved substances on the boiling point of water. You can see the diagram. Had a beaker over the burner. Then that beaker should contain the salt water. We had the stirrer. And then we have the thermometer. That's slanting line, the thermometer. Then the question says you are provided with a beaker, a thermometer, and a stirrer, a stopwatch, measuring cylinder, spring balance, some masses of table salt, and a heater or Bunsen burner. I measure 20 cm cube of water into the beaker. We have done that already. 2. I heat the water until it boils steadily for about 2 minutes. I read and record the boiling point BO. IV, with the water being heated, add table salt of mass 10 grams to the boiling water and stir continuously until another boiling point BI is attained. V. Read and record the value BI and evaluate theta equal to BI minus BO. VI. Using the same mixture being heated, repeat the procedure for M equal to 20 gram, 30 gram, 40 gram, and 50 gram. VII. In each case, read and record the BI and also evaluate B theta. VII. Tabulate readings. IS. Plot a graph with M on the vertical axis and theta on the horizontal axis. S. Determine the slope of the graph. SI. State the precautions taken to ensure accurate result. Then question B, I define boiling point of a liquid. BII, state two factors that affect the boiling point of a liquid. Then triple I, what is the heat required to raise the temperature of 2.5 kg of copper from 10 degrees Celsius to 35 degrees Celsius? Specific heat capacity of copper equal to 400 joule per kilogram per Kelvin. So let's go to the experimental setup and then start the experiment. So we're going to start heating the beaker. So the burner base is wide, so we cannot place this glass on top of the burner base because the base is narrow. So we have to use a container, an improvised container, to level the beaker. And then this is 200 cl water collected. Then this container, aluminum container, will have some water inside of it. So we're going to place this water in the beaker in it, and heat will be conducted by conduction from aluminum container to the water in the beaker. So we are started heating the water. The next thing we'll do is we'll get a thermometer and insert the thermometer inside into the beaker of water, and then wait for the water to boil. And according to the equation, we are told that the water should boil for about 2 minutes. So we're heating up the water now, and they'll have to exercise some patience. Remember that the heater, the flame is reduced so that it will go on a steady rate. You don't have to heat vigorously. So take it slow, and then that's what's going to happen. So at boiling point, when the water in the container boils, the water in the beaker will also boil because the heat is transferred at the same time. So we'll observe it and then wait for a minute and see what's going to happen. So the water is now boiling, and we'll allow it to boil for a few minutes. And the mercury level is at 100 degrees. So they are the boiling point of pure water. So water we use is very clean, 100 degrees Celsius. So that's the boiling point, and that's what we are noticing here. At the mercury level, the mercury is opaque. You see a dark line inside the thermometer stem at 100 degrees Celsius. So we allow it to continue boiling. You don't have to off your gas. We'll go and record our reading on the board, whiteboard. That's the boiling point of water at 100 degrees Celsius. So boiling point of water here recorded as 100.0 degrees Celsius. That's the boiling point of water. The next is this. We're going to add 10 grams of salt to the water and get the new boiling point. So here we have 10 grams of common salt added into the water. The water in the beaker has stopped boiling. Then the next is that we'll have to stir this water to dissolve the salt. We stir it. Then we put back the thermometer. And then allow the water to boil, or the mixture to boil again. So you see the mixture is boiling now, and the thermometer reading is constant, slightly above 100. So we have a 100.5 degrees Celsius. 100.5 degrees Celsius on adding the 10 gram mass that we have here. So record that reading on the board. So now I record 100.5. That's what we got here. Then we'll evaluate theta. Theta is going to be BI minus BO. That is 100.5 minus 100. That gives us 0.50024 SF. So we'll go back to the mixture and then add 20 grams of common salt to the boiling mixture. So here we have 20 grams of common salt added to the boiling mixture. So after adding that, we stir the mixture to make sure the salt is dissolved. So after stirring, we'll allow the mixture to boil once more. The mixture is boiling now. The temperature is steady at 101, about 101.5 degree. 101.5 degrees. So report our work on the whiteboard. So I have 101.5 degrees here. So to find theta, we'll have 101.5 minus 100. That will give us 1.500 degrees. So now we're adding the 30 grams of common salt inside the mixture. And then we stir the mixture to dissolve the salt. The mixture is somehow saturated, so you have to stir it very well to dissolve it. Then you allow it to boil for some time. So give some time to boil. You can now have the final temperature. So the mixture has started boiling, and thermometer is at around 102 degrees Celsius. 102 degrees Celsius. So report it on the whiteboard. So now I have 102.0 to 4 SF. The 102 minus 100 give us 2.00. So that is it. We now go to the 40 gram salt. So we now pour the 40 gram salt to the mixture. Stir it very well. So after stirring, we allow it to boil. The mixture is boiling, and we have around 102.5 degree. 102.5 degree. Report on the whiteboard. So 102.5. 102.5 minus 100 give us 2.500. We'll now go to the last mass, which is 50 gram. So add the 50 gram mass of salt added to the mixture again. Then that is it. Then you stir very well. And we'll have to also state it here that you must not use an aluminium pan to heat. You can still have an improvised, you can have a clamp, wooden clamp, which should be the best. With the wooden clamp, you can use it to hold the beaker and heat it directly over the burner, and it will make the water to boil faster than using aluminium can, since glass is not all that a good conductor of heat. So you have a wooden clamp, that will be better than using an aluminium. We'll have to use this improvised container because we don't have an aluminium clamp, a wooden clamp here. So let's allow the mixture to boil. The mixture is boiling, and the mercury is steady around 105 degrees. 105 degrees. That's the boiling point of this mixture. Okay? So with that, we can turn off the gas. So go to the board. So report 105.0 here. And then the difference, Bi minus B0, BO, that is 105 minus 100, that gives us 5.00. All values recorded to 4 significant figures. So we're going to the graph. We're going to plot mass on the vertical axis against theta on the horizontal axis, and then look at the shape of our graph. So we can see our processed result. The boiling point of water, 100 degrees Celsius. The experimental table have the serial number 1, 2, 3, 4, 5. So move to experiment 1. When 10 grams of salt was added, the boiling point was observed at 100.5 degrees. Then theta, which is Bi minus Bo, where Bo is the boiling point of water, 100. So 105 minus 100 gives us 0.5 degrees Celsius. Then number 2, when the mass of the salt added was 20 grams, the mixture boiled at, when more 20 grams of salt was added, the mixture boiled at 101.5 degrees Celsius. The difference, 101.5 minus 100 gives us 1.500 degrees Celsius. So the unit here should be degree Celsius. So you include that. Then when 30 gram, extra 30 gram was added to the mixture boiled at 102 degrees Celsius. The difference in temperature, which is 102 minus 100, gives us 2.0 degrees Celsius. Then, when extra 40 grams of salt was added to the mixture, the boiling point of the mixture became 102.5 degrees. The difference, 102 minus 100, gives us 2.5 degrees Celsius. Then, when extra 50 grams of salt was added to the mixture boiled at 105 degrees Celsius, and the difference is 105 minus 100, which is 5 degrees Celsius. So we are plotting mass on the vertical axis against theta on the horizontal axis. So let's go to our graph and scale the values for mass. The least value is 10 and the higher value is 50. So let's look at the graph. So going to the graph, the vertical axis is our M axis. So write M here. M in grams. So the vertical axis. And then the graph should start from 0. So write 0 here. So the values of M range from 0 to 50, range from 10 to 50. So we choose our scale. We can choose 2 buses to 10 cm. 2 buses means 4 centimeter to 10 gram. 2 buses to 10 grams, sorry. So we can put 10 here. So after every 2 buses, we put 10. The next 2 buses, we put another 10. That gives you 20 there. So then the error here should be 10. Next 2 buses is 20. 20 should be here. So we clean up the other one. Okay. So the next 2 buses will give us 30. That should be there. You can see it very well. 0. 2 buses, which is 4 cm, because the bus is 2 cm. So 10. And that 2 buses 20. And that 2 buses 30. Then the next 2 buses will have 40. And the next 2 buses will have 50. So our scale would therefore read 4 cm to 10 gram on M axis. 4 cm to 10 gram because each bus is 2 cm. So you can see very well. So 2 buses means 4 cm. So to 10 gram on M axis. So having done that, we now scale the horizontal axis. That is, the horizontal axis now, of course, is theta axis. Theta in degrees Celsius. So we'll see it very well. Horizontal is theta in degrees Celsius. So that's the horizontal axis. Theta. So let's look at the values of theta and know how to choose our scale. So the values of theta range from the least value of theta is 0.5 and the highest value of theta is 5. So range from 0.5 to 5. So let's go and scale the horizontal axis. So on the horizontal, we're going to use the scale of 1 bus for 1 degree Celsius. So here is 1, 2, 3, 4, 5. So why did I use one boss? Why don't I use 0.5? If I use 0.5, 0.5 here, 1, 1.5 here, 2, 2.5 here, 3, 3.5 there, 4, 4.5. So the higher value is 5, so it cannot enter. Even though that would have been a perfect scale. So we have to choose a bigger value, 1, 2, 3, or to 5. So for the theta axis, we can now say one boss, which is 2 cm, is equivalent to 1 degree Celsius. So the scale, 2 cm to 1 degree Celsius. So we now have here, we have a on the horizontal, we now say 2 cm, 2 centimeter, that is one boss, to 1 degree on theta axis. That theta is the horizontal axis. So you can see our scale. Before we go on to plot the graph, we know that the values on the M axis are well arranged. We don't have issue with the values on the vertical axis. So they are well arranged. You can easily count them without any difficulty. But where we have issue is the horizontal axis. So what do? What we have to do is we should find out what one line represents here. So on the theta axis, so since it's 1 degree or for one unit for one boss, and there are 10 lines in one boss, so we count what one line represents. So we can now say on the theta axis, one line will now become equal to 1 degree over 10. See that 10 lines in one line give us 0.1 degrees. So one line is 0.1 degree on the horizontal axis. So that can easily count 0.5, 1.5, those small values. So we can easily count it and then plot our graph. So let's go to the graphing. We'll now take the first graph or the first row. When M is 10 degree, our theta is 0.5. So we're going to plot 10 against 0.5. So let's count 0.5 on the horizontal axis. So on the horizontal axis, one line is 0.1. So 0.5 should be on the fifth line. 1, 2, 3, 4, and then 5. So that should be here 0.5. So move up to where we have 10. So we can see 10 on the vertical axis. So this is 10. 1, 2, 3, 4, and then 5. 0.5 and 10. So we have to mark here asterisk. So that is where we're going to plot. We can circle it. So you can see that. So we'll now go to the next value. For the second row or the second experiment, when the mass is 20 grams, our theta is 1.5. So we're going to count off 1.5 from the horizontal axis and then merge it with 20 on the vertical axis. Remember that at the horizontal axis, one line is 0.1. So with the horizontal axis is 1, length is 1.1, 1.2, 1.3, 1.4, and then this should be 1.5, the fifth line after 1. We'll now move to the we'll have 20. So this is 20. So from 1, this is 1, this line is 1. So this is 20. We'll count 5 lines from that 1. 1, 2, 3, 4, and then 5. So this point is 1.5. 1.5. So we'll mark it as asterisk and then circle that point. So you see that. For the third experiment, when the mass is 30 grams, our theta is 2.0 degree. So we're plotting 30 against 2 this time around. So value 2 is perfectly on the horizontal axis. So move it and then merge it with 30. So look at 30. So move to the line of 2. This is 30. And here is 2. So we mark here as asterisk and then circle. 30 merges with 2. So you can see our graph. Number 4, or the fourth experiment, 40 goes with 2.5. So let's go to horizontal axis and count off 2.5. 2.5 is the fifth line after 2. Since one line here is 0.1, 2.1, 2.2, 2.3, 2.4, and here is 2.5. So you can now move up to look for 40. So you can see 40 there. You can see 40. So, and this line here is 2. So 2.1, 0.2, 0.3, 0.4, 2.5, the fifth line that is there. So we'll mark it there and create our circle. So for the fifth experiment, when the mass is 50 grams, our theta is 5. So plot 5 against 50. So you can see 5, which is already on the horizontal axis. So move the line of 5 up to merge with 50. So you can move up until we get 50. So you can see that. So this is where they merge, this point. Where 5 merges with 50, we'll have to put our point here. So we'll have that. So you can see our graph. We're going to join the points that give us the best line. Our best line, where we'll have maximum number of points. So we can do that now. So we have a best line drawn there, cutting across almost 3 points. You can see the first point, the last point, that is the one where you plotted 50 against 5. Then have the second point and the first point. So in a straight line. So where these 2 points are out of the straight line, so you don't force them. So we'll have our graph here, and we'll have an intercept on the vertical axis. The intercept is close to 0. Is close to, this is 10, is close to 5. So 5 at the minute between 0 and 10, almost at 5. That will have the intercept. So next is we're going to take our slope. To take our slope, we're going to choose that point where you have where the last point where you have 50, and then we choose perhaps we're going to choose the first point and then the last point to take our slope. So how about that triangle, right angle triangle drawn from the fifth point out to the first point to have a long range. So to find the slope, the intercept or the coordinate on the m-axis, the upper coordinate is 50. Then the lower coordinate on the vertical or m-axis is 10. Then on the horizontal axis or theta, the higher coordinate is 5. And the lower coordinate is 0.5. And you know that slope is change on m-axis or vertical over change on horizontal axis. So let's go to the slope. So you can see our slope calculated, changing on m-axis all over change on theta axis, 50 minus 10 in grams all over 5 minus 0.5 in degrees Celsius. That gives us 40 grams all over 4.5 degrees Celsius. When we divide, we'll have our slope as 8.89 gram per degree Celsius. 8.89 gram per degree Celsius. Now, if you're asked to find the intercept on the vertical axis, the intercept on the m-axis is nothing but 5.0 grams. So that the intercept on the vertical or m-axis. The next question, SI says, state two precautions taken to ensure accurate results. State two precautions taken to ensure accurate results. Precautions. 1. I ensure that I avoided error due to parallels in reading the thermometer. 2. I ensure that I use pure water during the experiment. So if you use impure water, it will affect the boiling point. So 1, I ensure that I avoided error due to parallels in reading the thermometer. 2, I ensure that I use pure water during the experiment. Question BI says, define the boiling point of a liquid. Define the boiling point of a liquid. The boiling point of a liquid is defined as the temperature at which the saturated vapor pressure of a liquid is equal to the external atmospheric pressure. The boiling point of a liquid is defined as the temperature at which the saturated vapor pressure of a liquid is equal to the external atmospheric pressure. So that will define boiling point of a liquid. Go to the next question. BII says, state two factors that affect the boiling point of a liquid. State two factors that affect the boiling point of a liquid. So two critical or crucial factors include 1, temperature, 2, pressure. The other factors also that can be considered: 3, presence of solute or purity of the liquid, and then 4, intermolecular forces. So these are the factors that can affect the boiling point of a liquid. So any two is okay. Go to the next question. Question B triple I says, what is the heat required to raise the temperature of 2.5 kilogram of copper from 10 degrees Celsius to 35 degrees Celsius? Take the speed capacity of copper as 400 joule per kilogram per Kelvin. So let's solve this out. So we have heat or amount of heat required given as MC delta theta, where M is the mass, which is 2.5 kg of copper. C, the specific capacity of copper, which is 400 joule per kilogram per Kelvin. The initial temperature theta 1 is 10 degrees Celsius. Final temperature theta 2 is 35 degrees Celsius. Then we employ H equal to MC, change temperature. It's going to be 2.5 times 400 times the difference in temperature, 35 minus 10, difference between the initial and final. So that's going to give us 2.5 times 400 times 25. And that will give us the amount of heat required as 25,000 joules, or 2.5 times 10 power 4 joules. So with this experiment, we are seeing that addition of solutes or substances in a liquid such as water will raise its boiling point, as we saw in the experiment, and we treated some other questions and precautions in this experiment. So if you are not subscribed to the channel, tap on the subscription bell or button below the video that is playing. You see the tiny bells, so tap on it and get subscribed to the channel. Remain connected always.